Good evening, ma'am.
Good evening, Hari sir. So, shall I start?
Yes, ma'am.
Fine. Good evening, Ramya ma'am. Okay, I shared my screen. Screen is visible.
Yes, ma'am. Visible.
Hello. Is
Yes,
it
ma'am.
visible?
Screen is visible.
Yeah. Thank you so much, sir. So, I think yesterday I was talking about the correlation and regression. And I think I have made you clear this thing that correlation is helping us to find the relationship between the variables. Correlation is not a causation, means correlation cannot help you to understand cause and effect relationship. Although variable may have that kind of relationship, but that cannot be explained by correlation, right? So to study this, we are moving ahead and talking about the next statistical tool, which is regression. So regression can help us to understand the cause and effect relationship between the variables, right? Yesterday I explained you regression can also help you for the modeling. That is, we can also go for the forecasting of the dependent variable using the independent variable, right? Then we talked about the types of regression, especially I talked about the linear regression. I said there is simple linear regression and there is multiple linear regression, right? Linear regression, I think, is a regression where we are having only two variables. One is dependent, one is independent. Dependent variable is what? Dependent variable will be numeric. Even independent variable will be numeric. That means for performing the simple linear regression, we need to have two numeric variables, one dependent and one independent, right? We have also understood the concept of line fitting between the variables, that is modeling. So as we are talking about the linear regression, so we talked about the straight line, that is y equals to a plus bx, right? So in that I told you this is the mathematical equation, but when we are taking this equation in the statistics, we are introducing one more term, which is the E, that is the error term or the residual value, right? So residuals are very much important in case of regression because the assumptions are roaming around the residuals only, right? So residuals are playing a very important role because residuals are helping us to understand the accuracy of the model which we are fitting between the variables, right? So we have talked about the various assumptions. Yesterday I told you first one is the variable type. So we will be having two numeric variables. In case of simple linear regression, we are talking about, or we are more concerned about the normality of the residuals, equality of the variance in the residuals, and also the independency of the residuals. Means the residuals should be independent of each other, right? So these were the main assumptions we have talked about. Then we have seen that once we are performing using the LM function, linear method function we are using here, linear modeling function we are using to perform the regression, simple linear regression. So I think this is what we have done yesterday, right? And we have stored the performance or this particular function result into this particular object. And then we have seen its summary. So summary is giving so many things to us. We need to interpret all those things. It's not everything, but most of the things we are interpreting, which we need to report also. So we have talked about the intercept of the line. So that is the A value, that is y equals to A. A is the intercept, right? So intercept value is we will identify from the output. Also, we will see the coefficient of the independent variable, and then we need to see whether these are significantly different from zero or not. Meaning is that if they are zero, that means they are not contributing anything to the dependent variable, right? So if suppose I will talk about this. Yesterday I have written this, and suppose my line was y equals a plus bx. This was the line, right? Where in our case, Y was the MPG, right? A is 37.29 and B was minus 5.34. It is multiplied by weight, right? This is what we have seen. I think yesterday I have not made the hypo or this equation for you, but this way we can formulate our equation, right? Now, if I am having the car weight available or the weight of car is available to me, I can replace it here. I can solve this right side. I can go for the or getting the value of MPG. That means I'm predicting the miles per gallon for the car whose weight I am knowing, right? This way I can do the forecasting or the prediction, right? If suppose I'm talking about this line. So here, why I'm saying this? Because now we need to talk about, as I said, these should be significantly different from 0, right? So meaning is that if suppose I'm assuming the weight of car is suppose 0, meaning is that this term will be 0. So even then there will be some MPG, miles per gallon for the car. That value will be this 37.29. Similarly, if suppose I am saying that if this is constant or I'm ignoring this, and if suppose I am increasing the weight of car by 1 unit, so there will be minus 5.34 unit change in the MPG, right? So this way we can understand the relationship between these two variables. That is how we can understand that how weight is impacting the MPG of the car. In this, we have also seen after this interpretation, we need to also go for the reporting of the R square. Usually, when you are performing the regression in the R environment, generally R square is, if you have seen, I think I will be having that list. You can see we are getting this R square value and F statistic and P value at the end of the output. But usually if you are performing these things using some other software, we are getting these things before or at the first stage. So in that case, it is like we need to report these things first and then we need to report all these things, right? So R square is what? It is explaining us the how much variance the independent variable is explaining in the dependent variable. That is how much change is possible because of your independent variable in the dependent variable. So approximately this percent change, 75.28% change is possible in the DV, that is MPG, because of weight of the car, right? Then we are also getting the F statistic. F statistics is again a very important thing because it is ascertaining the fitness of the model, that whether your model is a fit model or not. So to understand the fitness of the model, we are talking about the F statistics. And for F statistic, we will look at the P value. Looking at the P value, we will comment whether the model is a fit model or not fit. After that, whatever output we are getting, one by one, we will plot the graph of all these things, and that way we will interpret them, right? So this was about the simple linear regression, which I have talked about yesterday. Today, I'll talk about the multiple regression. So anyone who can tell me what is the multiple regression? Yesterday, I think I told this thing. Anyone?
More than 2 variables.
More than 2 variables. Thank you so much, Harisa. Sir said very correctly.
1 direct variable and more than 2 indirect variables.
Good. Thank you, sir. So when we talk about multiple regression, multiple linear regression, I must say, we will be having more than 2 variables, right? We can say one will be the dependent variable, right? Which will be the numeric variable. And others will be the independent variables. These can be the numeric or categorical or both, right? So this is about multiple linear regression. Talking about the assumptions. So first assumption is based nothing but it is related to the type of your variable. This should be numeric, right? IV can be numeric as well as categorical or any combination, right? This is the first two assumptions. Then coming to the next is talking about the residual. Residual should be normally distributed. Then residual should be or should have equal variance, right? Then residual should be independent of each other. Then no collinearity. Right? So these are the some of the assumptions which you need to check when we are talking about the multiple regression, right? Yesterday, I have taken the data set. If you can recall, I have talked about the empty cars. Yes. This is what we have seen. Motor, trend, car, road tests, data sets. This is what I talked about, right? So all the description about this data set is available here. You can go through. Now I think I'm taking some variables. Firstly, what I'm doing, suppose I'm storing the empty cars into the object named as data. I can check out few lines of the data set. If I want to see the last few lines, I can go for the tail, right? That way you can see these are the various models of cars available in this data. Along with that, we are having the miles per gallon, number of cylinders, displacement, horsepower, dread, weight, cubic, PS, automatic or manual car, gear, carburetor. These all kind of things are given here in case of this particular data set, or in case of these different cars or different models of cars, right? So this is the things which we can see here. Now suppose I need to perform here the multiple regression. Now I have taken, I have taken three variables out of the mentioned variables, that is MPG, WT and HP, weight and horsepower. Now I want to, firstly I need to identify which will be my independent variable, which will be my dependent variable. So anyone who can tell me which variable I should take as an independent and which variable I need to take as a dependent variable out of these three? Anyone?
Ma'am, MPG is dependent variable on independent weight.
Okay. And HP?
Also independent variable HP.
Very good. Thank you so much, sir. So you can see, sir has said very correctly that MPG will be the dependent variable and weight and horsepower will be the independent variable, right? Meaning is that I want to see the impact of these two variables on the MPG, that is miles per gallon of the car, right? So now I'll firstly write the null hypothesis. So I have written there is no significant impact of weight of car on mpg, miles per gallon of car or something, only miles per gallon I have written. This is my first null hypothesis. So second I am writing there is no significant impact of horsepower of car on mpg. Right? Fine. So okay.
Yes, ma'am. Okay.
Fine. So that means two independent variables I was having, and I have made two null hypotheses. Right? Now I'll go to perform the multiple regression. So I'm writing here. Suppose I am storing my result or output in the result one object. The function which I need to use is the LM only. If you can recall, yesterday also we have used the LM function. So meaning is that either you need to perform the simple linear regression or multiple linear regression. In both the cases, we will use LM function, right? Inside this, you need to pass the name of your dependent variable first, which is MPG. Then tilde sign I'm using here, and then I need to pass all my independent variables. That is WT. These will be separated by the plus sign, right? And I think I stored my data into the or data set into the data object. So I need to give the name of my data set. So I am giving the data because I stored my data set into this, right? Is it fine? I'm pressing Control Enter now. So I think you can see it is successfully run. No error you are getting in the console. Now, I'm want to see all my outputs. What I'm using here the object called, sorry, whatever the object I have used here to store the output, I am passing that into the summary function. I am pressing Control Enter. I hope output is visible. You can see so many things you are getting here. So I'll talk about firstly about the residuals. So whatever the residuals will be coming on the basis of this data, you can see the minimum residual value is the minus 3.941. The first quartile of the residual values are minus 1.6. Median of the residual is minus 0.182. Third quartile value is 1.05. And the maximum value of the quartile and the maximum value of the residual is 5.854. Now we will go down. Firstly, we will interpret these things. That is R square. We will interpret. So I think if you can recall, I told you when you are performing the multiple linear regression, you need to report adjusted R square instead of R square, right? R square we need to report in case of simple linear regression. So I'll go with this. I'll talk about the adjusted R square. Interpretation of both will be same, whether it is in simple R square, whether it is adjusted R square. The interpretation will remain same, right? Only it is you need to pay attention which will you will report when. So again, I'm repeating. For the simple linear regression, we need to report R square. For multiple linear regression, we need to report adjusted R square, right? Now I'll talk about the interpretation. So you can find here adjusted R square value is 0.8148. That means it will say 81.48% variance in MPG is explained by weight and horsepower of car together. Right? Means both the independent variables collectively interpreting or explaining approximate 81.48% variance in the MPG, right? Means how much change is possible in the MPG when you are considering the variables like weight of the car and horsepower of that engine, right? So that way you can see it is in, sorry, weight of the, not car, weight of the engine and horsepower of the engine. So it is approximate 81.48% changes is possible in the MPG, right? Is it clear? Is it okay?
Yes, ma'am.
Fine. Next one is the F statistic, which is, I think I told you, it will help you to understand the fitness of the model. So once you will look at this value, you can see, especially the p value. This value is what? It is 9.109 e minus 12, which is very small figure, which is less than 0.05. So conclusion will be model is good fit, right? Fine. Till here, I think I'm clear.
Ma'am, could you please repeat this? I missed
Okay.
how you conclude.
Okay. I said F statistic value is this. Degrees of freedom are 2 and 929. And the p value is 9.109 e minus 12. So I've said you need to look at the p value. This p value is very small. It is less than 0.05, right? So meaning is that we can say that model is a good fit, right? So you need to look at the p value of your F or ANOVA, so which is indicating you whether your model is a good model or not, right? So we can say our model is a good fit. I think it is clear now, sir.
Yes, ma'am. Clear. Thank you.
Yeah. Now we will proceed to the next thing. Just a minute. Hello. Yes. Hmm. हाँ बच्चे. Sorry for the inconvenience. Again, I'm coming back. Now I'm talking about the remaining output. So till here, I think if I'll clear, I'll go ahead, I'll talk about this coefficient table. This coefficient table is helping us to understand the contribution of these things in the dependent variable. So you can see intercept value is 37.22727. Weight value is minus 3.87783. Horsepower value is minus 0.03177. We need to conclude our results on the basis of the p value of the t-test. So these values, if you will look at the first value, again a very small figure. Second value is again a small figure. Third value is also a small figure. And you can see the three asterisks are here. So if three asterisk I'm talking about, these three stars or asterisk are saying that your results are, means this intercept is significant at 0.1%, right? Similarly, the weight coefficient is also significant at 0.1%. And lastly, this this 00 is 1%, right? That means the coefficient of horsepower is significant at 1%. So this is the meaning. So, hello. Hmm. बच्चा अभी आया मैं ना सेशन करती हूँ. Sorry. Okay. So I think it is okay, clear what I said. Is it clear, friends?
Yes, ma'am. 1% significance.
Yes. Just a minute. Fine. Now, moving ahead, when all these things are significantly contributing to my dependent variable, that means I can go to talk about my hypothesis. So all these things, all the p-values are less than 0.05. Meaning is that the two hypotheses which I have made, these I am not accepting. I am rejecting this because my data is not supporting them. So what I will say there is a significant impact of weight of car on MPG, and there is a significant impact of horsepower of car or engine, not car, engine on MPG. Is it okay? I need to write here engine. Is it fine?
Yes, ma'am. Yes, ma'am.
Yeah. So now if it is all fine, now I will write my equation. So equation will be y equals to a plus b1 x1 plus b2 x2, right? So I'll write MPG is equals to a is 37.23. I have rounded off this, right? Minus 3.88 multiplied by the weight, right? And then minus 0.03 multiplied by horsepower. Done? Clear? It is fine.
Yes, ma'am.
Now, I'll go and talk about now you can see I'm getting my first, what I can say, the plot. This plot is for the variance. You can see here the middle line or the zero line, which is the most middle in this particular box. And then you can see the circles which you are looking. These are what? These are the residuals value, right? So now you can see the whether means you need to observe here whether these circles or whether whatever the distribution of these residuals is, whether they are forming any shape or not. So these should be scattered here and there. They should not form any shape, right? So in that case, you can say there is a homogeneity of variance or there is a equality of variance. So you can see here, if I will look here on the middle line, the zero line, I can see almost there is not almost equal, but you can find here at the bottom or at below of the zero line, you can see there are more concentration of the residuals in comparison to the upper side of the zero line, right? But if you will try to find any shape, I don't think so you will be able to see any shape. Shape meaning is whether there should be any cone type of shape or fan type of shape you are able to observe. But I think when you will look at the data, you can see we are not finding any shape here. So meaning is that we can say that residuals are having the equal variance. So this is what is the meaning of this particular first plot. Is it clear?
Yes, ma'am. Clear.
Fine. Talking about my second plot, you can see this is for the normality. QQ residuals. Quantile is for the understanding the normality of my data. So once you will look at this data, you can find here that this is the fitted line. And if you will see the residuals distribution or residuals are almost parallelly or they are coinciding your this fitted line. That means your residuals are almost following the normal distribution. Although few deviation we can find here at the upper side, some of the residuals are not exactly coming. They're not overlapping this particular line, but remaining residuals are almost on the line. That means I can say residuals are approximately normally distributed. It is okay. Is it fine?
Fine, ma'am.
Fine. Next one is for finding whether any influencer value is there in your data or not, right? So what I'm doing, I'll check the length of my data. I'll check the length of my data first. So I'll see uh, 32 observations, right? So I want to get the value of 4 by 32. 0.125 means 0.125 if any of means for all the 32 values. We are having total 32 values of or pairs of the data in the this particular data set. So the influential value will be what it is 0.125. So you need to check 125 will be coming somewhere here, right? This will be somewhere here. So above that value, all these values are influential values. That means these figures are or these values are impacting my what I can say the model, right? So this way we can conclude there are influential values available in my data which may or which are impacting our model which we have created here, right? So this way you can perform the multiple linear regression in case of R. So it is about the multiple linear regression. Yeah.
Please repeat the last
Last line.
conclusion.
Okay.
Yes,
Again,
ma'am.
I'm repeating. This is, I'm writing here, for influential value. We generally use Cook's distance, right? Cook's distance is what? This is nothing, but this is 4 by n. So in our case, n is what? It is 32. We are having total 32 observations, right? 32 pairs of observations. In our combination, because I'm having the 3 variables, that means 32 pairs of data I am having in this particular data set. Now you can find 4 by 32 I calculated here. So 4 by 32 has given me the value as 0.125. 0.125 meaning is this is your threshold value. Now for every data set, for every observation you will check if for any observation this threshold value is or means any observation is now exceeding this particular threshold value. That means that particular observation or that particular model card model is influential data for my results, right? So here you can see 1.125 will come somewhere here, right? Because it is 0.2, that means it is 0.1. So 0.1 and little above to this will be 0.15. So this will be my threshold, right? So above this, if you can see, this is the Chrysler Imperial, right? Toyota Corolla, then Maserati Bora. These are the 3 models of the cars. These are the influential value in my model. So if I will drop these 3 rows data, so maybe I will get the better Cook's distance, which is acceptable for me. I think now it is clear, or do I need to repeat again? Hari sir, it is okay?
Yes, ma'am. Thank you, ma'am. Clear now.
Right. So now I think I will conclude on the all the 10 days what I have discussed in this particular FDP. And then as today's session was for the case discussion. So as you people are not interacting much, I'll try my best. I'll show you few of the cases. And if anyone wish to discuss those, so maybe that way I can try to take this session ahead. Is it clear what is the meaning?
Yes, ma'am. Yes, ma'am.
Right? So I'm firstly concluding all 10 days topics which we have discussed, and then I'll show you a small caselets. If you wish to see a read and want to tell wanted to discuss with me that in this particular scenario, which will be the appropriate statistical test that will be, I'll go ahead. That will go ahead. Is it fine?
Fine.
Fine. So I'm now concluding firstly what we have done till now, right? So as this was a 10-day long FDP, right? In this FDP, we have started our journey from understanding about the R and R Studio, right? On day 1, I talked about R and R Studio, we have seen the installation part of R&R Studio. On the same day, I also talked about the types of data, means what are the various types of data possible in the R. So we have seen there is possibility of numeric, integer, character, complex and logical data we can deal in the R, right? We have seen various kind of, means we have created various objects of these various types. And then we have also performed some of the arithmetic operations on those created objects. Day 2, we have started with our journey with the data structures, right? So data structures are playing very important role in the R, because we have seen the limitation of the object creation. Once I'm creating a small variable, say for example, I created a variable X. I have stored a single value, say for example, 1 or maybe 5. So it at a time, it will only take one value. But when we are talking about the analysis, we know we need to store a number of observations in any particular object. So in that case, we need to move and we need to see or look at on the data structures. So data structures are the facility in the R which are providing us to store the more than one observation in that, right? So on day 1, we have seen the 3 data structures, that is the vector, list and the factor. So vector, I told you, vector is atomic in nature. That is the same kind of data you can store in the vector. These are generally one dimensional. Various methods we have seen to create them, like C function, SEQ, REP, colon. These are the various ways we have seen to create the vector in the R. Then we have talked about the second data structure, which is list. So I told you list is heterogeneous in nature. Heterogeneous meaning is that we have seen the limitation of the vector. Vector can store same kind of data. But list is the data structure which can store the different kind of data, right? Like you can store the integer also, numeric value also, the logical value also, everything you can store in the list. But lists are also one dimension. Then we have seen using the list function, we can create lists in the R environment. Apart from that, we have also seen merging of the list, how we can name the element of the list, etc. Things we have seen. We have also understood the concept of indexing. Indexing is very important because you need to understand this thing if you want to pick some value from a specific object. So how you can do that? So using the indexing, you can do that, right? Then we have talked about the third data structure, which is factor. So factor was what? Factor is helping us to convert our data or the character data into the categorical data. So to convert a simple character data into the categorical data or simple qualitative data into the categorical data, we are using the factor function, right? So factor is a function which can help us to do this. So this way, this was the second day journey. Third day, we have seen the remaining 3 data structures, that is matrix, array, and the data frame. So matrix and array, as I told you, generally, if you are going for the mathematical kind of analysis and all, we will generally using the matrix. Similarly, for age processing or multi-dimensional data, we are using the arrays. So we have not discussed much about them, but we have seen how to create them. So matrix function we are using to create matrix, and array function we are using to create arrays, right? Also, we have seen indexing in both the contexts, in context of matrix and in context of array also. Then we have talked about the data frame. So data frame is very important data structure in R, especially when we are talking about the analysis, statistical analysis, right? So we have seen data frames are the 2-dimensional thing, that is a row and column kind of arrangement of the data. And these are heterogeneous in nature. Column wise, you need to store same kind of, means column wise they will be homogeneous, but one column can store one type of data, other column can store other kind of data. So this way, this is the data frame. Data.frame function we are using to create data frames, right? The syntax of creating them is very easy. We have seen some functions like head, tail, structure, summary when we are talking about the data frame. Then on day 4, we have talked about the descriptive statistics. we have understood the concept of descriptive statistics. We have performed them using the what I can say, using the R, right? Also, we have talked about that measures of central tendency, measures of dispersion, and measures of skewness. This is all we have talked about. We have also understood the concept of missing value, and if missing values are present in the data, how we can perform or get these different descriptive statistics. This is what we have discussed. Then we have talked about the distribution. So we have seen or understood the concept of distribution. We have seen the distribution like the discrete and the probability distribution. So we have talked about binomial and the Poisson in case of discrete distribution, and then we have talked about the continuous probability distribution in case we have talked about the normal probability distribution in case of continuous distribution. So this is what we have done. We have seen various numerical aspects of these different distributions. We have seen there are various functions which are like suppose I say R norm, D norm, then P norm, then Q norm, and then R norm. These are the different functions we have seen. All the functions are their own meaning, and for their own purposes we are using them. So this is about the distribution of the data. Then we have talked about functions and packages. So there is basic function that is by default function, and the user defined functions, right? So I think so many basic functions we have used till date. And also I told you, if you wish to create your own function, so how you can create that? So you can use the loop like for loop, if loop, while loop. These all different loops we can use for our own purposes. This is what we have seen on next day. Then we have started our journey from the analysis of the data. So after understanding the R environment in a good context, in a context where you can now use or perform the analytical or data analysis, so we have started our journey with the non-parametric test, that is the chi-square test, right? So we have seen both of the both types of chi-square test, that is goodness of fit as well as the independence of attributes. So we have understood one categorical variable is required in case of goodness of fit, and two categorical variables are required in case of second kind of that is test of association or independence of attributes kind of chi-square test. So we have seen chi-square dot test function is used here to perform chi-square test. Then we have started our journey next day from the parametric test. We have understood the concept of parametric test. We have seen first test was the t-test, right? So we have seen the meaning of the t-test, variety of the t-test. There is one sample and the two samples t-test. In two samples category, we have seen dependent and independent samples t-test. T-dot test function we are using to perform t-test in R. We have got the output, we have interpreted that in the R environment. Then we have talked about ANOVA, that's analysis of variance. So I told you it is the extension of independent samples t-test. In case of R, no, not R, maybe when we say statistics, so it is an extension of one independent samples t-test, because in the case of independent samples t-test, we can only see the significant difference in the two categories. But when you are having more than two categories and you want to compare all categories for the mean, so you will go for the ANOVA. In ANOVA also we have understood there are two varieties, one-way ANOVA and two-way ANOVA. One-way ANOVA is restricted, that means it is requiring only two variables, one dependent and one independent variable, or you can say one numeric and one categorical variable. So you will formulate one hypothesis and using the AOV function you can test it. Then in case of two-way ANOVA, you will be having the two-way kind of table. You can say you will be having the two categorical variable and one numeric variable in case of two-way ANOVA, right? Now, two-way ANOVA is a case where we can see the main effect also, and also we can see or observe or measure the interaction effect also, right? So you need to formulate total three null hypotheses in case of two-way ANOVA. Two for the main effect, that is individual effect of your both the independent variable, and third will be of the combined effect, that is you're combining both the independent variable and you want to see their impact on the independent variable. So this was the two-way ANOVA. Same AOV function we are using to perform it, and that way we have seen the interpretation. Yesterday I talked about the correlation and the regression. So I told you correlation is used for the finding the degree and the direction of the relationship. It cannot help you to understand cause and effect relationship. To understand this, we are going for the regression. So regression is having multiple uses, like it can help you to predict your dependent variable. Also, you can go for do the modeling of the variables. These kind of things you can do. Then we have seen we are having two linear regressions, that is simple and the multiple. In case of simple, we are requiring only two variables, one dependent, one independent, that is both will be the numeric variables. We will formulating one null hypothesis, and that way we are checking it using the LM function. LM function we will use here, and then we will perform the regression, and then we will get the summary of that. We can interpret easily. You need to report R square, you need to report F and its p-value, you need to report all the coefficient, and you need to find whether they are significant or not using the p-value of the t-test. This is what we have understood in case of simple linear regression. And today I think I am not repeating, because today only I discussed the multiple linear regression. So this was the journey of the 10 days which we have sailed together. Now I think I'm going ahead. If you people will permit me, I'll show you some of the situations, and if you wish to interact, because interaction is must, because in this 10 days FDP I have experienced that the involvement was not that much from the participant side, although it was not with me in my previous sessions. So involvement is must in this next activity. So if you say, I'll show you the caselets if you wish to discuss. So what you say, do I need to go ahead? Yes.
Yes. Yes, ma'am.
Fine. Okay. So thank you so much, sir, for saying yes. I'll just share my next screen and just stop sharing this. Screen is visible.
Yes, ma'am. Visible.
Fine. I'm requesting you to please go through the situation and then tell me what you are understanding with this, and if you are understanding, which statistical test we can perform on it. Yes. Anyone? If you wish, you can write. Okay. Ranjita ma'am is writing. I think it's Ranjita ma'am. Ma'am is writing. It is correlation. Fine. Anyone else?
Correlation, ma'am.
Sorry, Hari sir. It's
Correlation.
It's correlation. Fine. Any other opinion? Any other answer from your side? Yes, friends. Any other answer? Is everyone is okay with correlation? No? Yes. Okay, I think not interested in interaction. Fine. So when I say the problem is saying a researcher wants to examine.
Ma'am,
Yeah.
Can we use chi-square?
Yeah,
Yes,
Hari sir.
ma'am.
Thank you. It is the correct answer.
Yes, ma'am. Yes.
Yes, it's a correct answer, because you can see problem says a researcher wants to examine whether smoking status, that is smoker, non-smoker, is associated with gender. among
Ma'am,
college students.
this is a case of non-parametric
Yes,
situation.
both the variables are categorical here.
Yes, ma'am.
Means we can say gender, male and female, and whether you're a smoker or non-smoker. Yes and no kind of thing. So that way you can see how many of the male are saying they are a smoker, how many of the male are saying they are non-smoker, how many of the female are saying they are a smoker, how many of the female are saying they are non-smoker. So that way that will be a two-way grid or 2 by 2 grid will be having to us. You will be having the count of frequency. So it is a case of chi-square. Thank you so much, Hari sir. Ranjita ma'am, I hope you got the answer. Yes. Fine, Ranjita ma'am, fine. Maybe I think ma'am is listening. Fine. Shall I go for the next situation?
Yes, ma'am.
Fine. I have shown you. I hope it is. Yes, Ramya ma'am. I hope it is visible. Sir, can you read it? Sir, my screen is visible.
Yes, ma'am. Visible. It is readable.
Okay, fine.
Ma'am, I think this is a case of correlation.
Yes, very correct, Hari sir. This is a case of correlation because you can see linear relationship is mentioned, and second thing is both the variables you have taken are the numeric in nature. So this is a case of linear relationship or linear correlation, right? You will perform here the correlation. Clear?
Yes, ma'am.
Fine. I'll go for the next now.
Ma'am, this is
Hmm.
a case of regression because here modeling is required and modeling is typically use of regressional analysis.
Very good. Thank you so much, Hari sir. This is a case of clear-cut case of regression. Question is, a housing economist wants to model the house prices based on variable such as area in square feet, number of bedrooms, location rating, etc. Right? So which regression, sir? So which regression we will perform here?
Ma'am, since there are more than in one independent variable, so this is case of multiple regression.
Very good.
Multiple regression, ma'am.
Yes, very good. Thank you, sir. Next.
Here two groups means ANOVA can be used.
A pharmaceutical company wants to compare the average blood pressure. Okay.
One.
It's ANOVA.
Yes, ma'am, I think so. In
Okay, fine. What about other participants, other friends? It is a case of ANOVA. According to you, what is what the test we can perform here? Yes, Ramya ma'am, Ranjita ma'am, which test we can perform?
ma'am, t-test can. I am confused in this case.
Which T, sir?
Mm,
Sir, if it is T, which T?
I'm right now unable to recall.
So which T according to you?
I'm able to recall right now, ma'am.
Okay, unable to recall. Fine. Anyone else? Ranjita ma'am? Ramya ma'am? Anyone? Fine. Okay, not so sure. Okay, fine, Ranjita ma'am. Okay, so situation says a pharmaceutical company wants to compare the average blood pressure. Average blood pressure meaning is mean. Ramya ma'am is saying independent titers. Fine. Between the two groups, so according to the Ramya ma'am, it is the correct answer. It is a groups you need to compare, and both the groups are independent. One is taking the medication, other is on the placebo. That means two independent groups you are having. There is no relation between them. You will go for the independent sample status. Is it clear now? Fine, sir. Fine, ma'am.
In independent one should be numeric. That is, dependent variable should be numeric. So,
Dependent is numeric, no, sir. Blood pressure is numeric,
okay, ma'am. Got it.
right?
Yes, ma'am.
Yeah. Next. Yes. Anyone?
Ma'am, it seems case of ANOVA test.
Case of ANOVA. Okay, fine. What about others? What about others? It's a case of ANOVA. Ranjita ma'am, Ramya ma'am, anyone else? Chi-square test, Ramya ma'am is saying. Fine. Any other opinion, Ranjita ma'am, from your side? Variance and ANOVA. Okay, Ranjita ma'am is saying ANOVA. Okay. Hari sir, you are also saying ANOVA?
Yes, ma'am, I think so because there are three groups and genders included. So I am guessing.
Fine. Okay. So according to me, it is a case of chi-square test. Why so? Because you can see both the variables are categorical. One is product preference, other one is the gender. So
Yes,
how
ma'am.
many of the
Yes.
male are saying for A, B, and C? So we will be having the count, right? Right, sir?
Yes, ma'am. This is
This is the
chi-square.
case of chi-square. So I hope Ranjita ma'am, it is clear to you also. Ramya ma'am was correct. Thank you, Ramya ma'am. Moving ahead. Next problem is visible, I hope. Yes. Any opinion? Ranjita ma'am is saying variance as I have to check effective. Okay. Ram ma'am is saying independent test fine. Harisa, what about you?
Ma'am, I am confused here. No opinion.
Okay, fine. So I think Ranjita ma'am said ANOVA. I think I recall. I think ma'am is correct. Because here you can see you need to compare the average test. It will be case of either T or ANOVA. That is clear, right? Now we are having how many different teaching methods, student? 3, right? So suppose 10 students I'm taking from each method. I'm having the score of them. So I can compare the average marks. Is it fine? So it is a case of ANOVA, one-way ANOVA. Is it clear now, Hari sir? And I think to Ramya ma'am.
Yes, ma'am.
Yeah. Moving to the next. Yeah, next.
One way and what test?
It's a one-way ANOVA. What about others?
Before and after comparison.
Okay, fine. What about others? What about others? Ramya ma'am, Ranjita ma'am. Any opinion? Okay, Ramya ma'am saying ma'am is confused. Fine, no problem. Anyone else? Ranjita ma'am, according to you? Ranjita ma'am, according to you? Okay, fine. So this is a case of independent sample t-test. This is not, sorry, this is a case of dependent sample t-test. That is paired t-test.
Yes, ma'am. Got it. Dependent.
Because if
sample
there is a
test.
pairing,
Yes, ma'am.
for the same people, we are collecting weights 2 times. Right, sir?
Yes, ma'am. Yes, ma'am. Right,
Yes.
right.
Yes.
Dependent sample t-test.
Yes, very good. So I think Ramya ma'am, Ranjita ma'am, it is clear to you also. Shall I go for next? Yes. Ramya ma'am is saying ANOVA. Okay, fine. What about others? Ranjita ma'am is also saying ANOVA. Fine. Hari sir, according to you?
Ma'am, since there is a single sample, so I think t-test should be used.
Which T, sir? One sample test, right?
Yes, ma'am. One sample t-test.
Very good. It's very
Single
correct.
sample used here.
We are having a
One
single
volt.
sample. Yes. Ranjita ma'am, Ramya ma'am, I think sir is very correct. As you can see, we are having only the one sample, and in that sample we are having 20 bolts. So we want to compare their mean with the company claim. That is, company is saying the bolt, what is it is asking? Diameters. The bolt diameter will be 1 centimeter. We want to claim the check. So we want to check the claim. What we are doing, we have taken the 20 bolts and we want to take their diameters, we can get their mean. We will compare with that, and that way we will comment whether the company claim is correct or not. So it is a clear case of one sample details. I hope it is okay, clear to you both. And I think remaining one, yes. Fine. Good. Next. After this, one more I'll take, and then we will conclude the session, right? Ranjita ma'am is saying two-way ANOVA, fine.
Ma'am, here I think chi-square test or correlation can
Class
be
test
applied.
and correlation, fine. Ramya ma'am is saying independent substitute. Okay, fine. We will see this question like this. Suppose this is a problem, right? We can see firstly the weight loss will be the numeric variable, right?
Yes, ma'am.
Then we are talking about the remaining two variables, that is different diets. Which type of diet a person is taking, and the exercise routine. What is the routine of the exercise? So in this case, these remaining two variables are categorical, right? Fine.
Yes, ma'am. Two
Now,
categorical and one numeric.
yeah. So now if I want to see the difference in the mean weight loss, so I'll go for the two-way ANOVA, right? Because two categorical variable and one numeric variable I'm having. And if I want to see the impact of diet plan or different diets and the exercise routine on the weight loss, I'll go for the multiple. I'll go for the multiple linear regression. Thank you. Yeah. Sorry for the inconvenience. Again, I'm coming back. So I think what I said is clear now. Fine. So one last problem I'm taking now, and then we
Ma'am,
will end. Fine. Now you can see.
ma'am, here scores are numeric values, while online versus offline are categorical values.
Hmm.
And if we are taking means and I think ANOVA, one
ANOVA,
way
the
ANOVA,
one
one
way.
way ANOVA.
Okay. Fine. What about Ramya ma'am and Ranjita ma'am? Ramya ma'am is also saying ANOVA. Fine. Ranjita ma'am, your opinion? Anything you want to say? Same. Fine. No, it is a case of independent samples. Only I want to compare the marks of two groups: students who are studying in the online mode, students who are studying in the offline mode. So two groups I am having only. So this is a clear case of independent sample status. Clear. Fine. Is it okay?
Okay, ma'am.
Fine. Fine, Ranjita ma'am. Thank you. So I think this way, I think I have completed the 10 days journey. So now I think I'll say this thing, that I hope this FDP will help you out to understand the use of R in your research journey, and maybe these sessions can help you to perform R. Right. So this is all from my side for this FDP. Thank you so much, everyone, for attending the FDP and bearing me throughout the 10 days. Thank you so much. If any queries you people are having, the platform is open for the same. Yes, any queries?
Thank you so much, ma'am.
Thank you, Harizat. Yeah, any query? No queries? So if there are no queries, I think we are done for this 10 days journey. Hope this session will help you out. All the best from my side for your research journey. Especially, I wish you please use art for your research, right? Okay, Ramya ma'am is not there on a WhatsApp group. Fine. Yoga sir, are you there? Sir, can you share the WhatsApp link on the chat? Yeah. Thank you so much, Deepak sir. Yeah, I think, ma'am, you can see, find the link is there on the chat. I hope you found. Yeah. Thank you. So I think this is all, friends. If there are no queries, we can end the session. So can we end the meeting for the day? Friends, there are no queries. Can we call off the meeting?
Yes, ma'am.
Yeah. Thank you, Hari sir. So Yoga sir, we are done for the day. Thank you so much. Team RFI, Ajay sir, Saurabh sir, and Yoga sir. Thank you so much, sir.